reduce the weight of the whole system, which is very helpful for spacecraft. And so they've been able to be a lot more effective. And so we think that this will be the last one, and look forward to a successful test here in a few hours.
Now I know a lot of people think when you think of parachutes, you just deploy a big parachute and float down to the earth or to the ocean. Is the parachute sequence really a lot more complicated than that?
It is a lot more complicated because you've got a spacecraft that gets launched into space, and out there in space it's plus 270 degrees in the sun and minus 270 degrees in the shade. So it has to go ahead and live through that environment for the length of the space mission. The first manned Orion mission right now is looking at 9 days to leave Earth, go around the moon, and come back. So it's in that environment, all packed and cold. You've got the parachutes that are packed in literally to the density of like oak wood. I mean, it's that well packed in the system. And so to keep them protected from MMOD and for other space stuff, they go ahead and have a forward bait cover that it sits over top of it. And so the first thing that's going to happen is the forward bait cover comes off. So parachutes come out of it, so the forward bait cover can get lifted off to expose the drogue chutes, the pilot chutes, and the main chutes. And so that's the first part of the choreography. Then the drogue chutes come out. The test today is about 25,000 feet or a little over 300 miles an hour. And they then stabilize the chute and slow it down to about 130 till it gets down to 9,500 feet, until then the pilot chutes, the 3 pilot chutes come out, and they then pull out the main parachutes at 9,000 feet. So you got 11 parachutes, all in sequence, the whole system to just slow the spacecraft down from 320 miles per hour down to 20 at touchdown is all assembled in flight. So yes, it's complex and it's an art, and there's certainly a great team here that we put together with NASA and our contractors and commercial partners to be able to unite and make this test complete. And here we are 4 years from flight to be able to check this one off saying, hey, we're ready for flight.
So when you do a space flight, how fast is the capsule going when it hits Earth's atmosphere?
Well, when we are coming home from low Earth orbit, which we've been doing for the last 18 years continuously on the space station, and I did this Friday will be 9 months since I came back and landed. You're doing 17,500 miles an hour. And so that equates to about Mach 25. Well, coming back from the moon, the speeds are a lot faster, and you're actually coming back at Mach 32. And so, 23,000 miles per hour is approximately what it is. And so the heat generated on the heat shield is a lot more, but once you get through the atmosphere, ideally the start conditions are about the same, around 300 miles an hour.
How fast is the spacecraft going when the first parachute deploys?
In this case, today, the test point is like about 327 miles per hour.
Well, I mean in reality, once you do a space mission.
I believe it's similar to that.
Okay, so how much?
320 or so miles per hour. The heat shield slows it down through the atmosphere, and then the parachutes start going.
And then how fast is it going when it hits the ocean?
20 miles per hour is the target.
Yeah.
So it's a small car crash.
Yeah.
But it's, hey, you're hitting water and not solid. When I landed 9 months ago, it was on solid ground in the middle of Kazakhstan, and so it was a bit more abrupt.
Well, Mike Sheldon, our city councilman, he asked a question back where we met downtown, and we couldn't answer it. So we asked it for him. Is NASA looking at landing on land rather than in the ocean?
With Orion, no, because of the weight of the capsule. Every pound is precious because we have to lift it up, fly it around, and then bring it back. And so to have a propulsive system to land with the rockets and enough propellant and all that, it would add too much weight to the spacecraft.
I see.
There are some companies that are considering that idea, but none that are actually doing it right now.
Mm-hmm. Okay.
Can you tell us a little bit about your experience in space?
It's a small question.
How was it?
Well, I just got back 9 months ago from 139 days aboard ISS for Expedition 52 and 53. Over 300 experiments were conducted, either that we were directly involved with or that we observed and managed while we were on board conducting science. We did 3 spacewalks to do repairs on the outside of the space station. We had it was like 4 different cargo vehicles come on up to bring supplies. also taking science back down to the Earth, as well as removing the trash from the space station. It's amazing. It was also the first time that we had 4 USOS, or we say US side of the space station, crew members up there. Typically we only had 3, and the Russian segment had 3. In our case it was 2 on the Russian segment and 4 on the US, so we got a ton of work done on space station, did a lot of mechanical work and maintenance work that had been put off for years because we're trying to get all the science done, and so really had a successful mission in making station a lot better than it was before, as well as getting all the science done that needed to be done.
Randy, I'm a solar system ambassador, and so I play your videos when you guys were on the space station to elementary schools.
Awesome.
And especially when you guys were playing with the fidget spinners. Oh, does that get a crack up out of the kids?
Good.
That and the pizza, making the pizza in space. So how do you guys go about or figure, or is that just, you just do it?
I was down at a store on the ground before I left for Russia, and my kids, saw the fidget spinners on the counter next to the cashier. Like, Papa, get us one of those. I was like, well, everybody had them at the time. I said, well, why don't I get one and take it with me? So my daughter picked out the red one, and I put it in my stuff and took it up with me. And it was neat because it was popular at the time. It's one of those passing fads, but it's also one of those things that they can relate to. They've had it in their hand. They know how it operates, and to be able to show them that you can spin it and just let it go, and it's just stable, and there's no gravity, no drag, and it would just keep spinning, and we could poke it and move it around and have fun with it. That was a neat way to connect with kids, to hopefully get them interested in picking up all the experience and the work that we've done over the years. When it's time for us to retire, we've got young people who've been interested and carry the torch into the future. The pizza, somebody had asked what would taste really good. I said pizza, on the next cargo vehicle it was there, and so it was there, the whole package, and as you can see from the video, it was fun making them, and I'll tell you what, I've had some good pizza, but that was, to me, I think the best in my life, because it had been so long. It was the texture, the taste, the smells were so different than our regular space food. It was delicious, and we call them the flying saucers of the edible kind.
That's great. And also your sounds and visions of silence.
I'm glad you appreciated that.
That is one of the best videos that I've ever seen from you guys putting those pictures together.
That's awesome, because we have lots of pictures and video, but it's hard to, when you're looking at a screen this big, to give the people the idea of everything you can see with your eyes. And so to get that kind of emotional feel of seeing your home planet as a human being, in 90 minutes as you go around it, putting the music to it was our best hope, to try and connect the two, to give you guys that feeling of what it's like to be, on that outpost, going around the Earth, and just seeing how finite it is, but also just how amazingly beautiful it is.
Oh, the music's perfect too, how it starts off slow and it just builds and builds to the climax. That was perfect.
I still never get tired of hearing that song, because it, to me, brings back the images of space, in my mind.
And also, what's the deal with Comrade?
It's I'm a fighter pilot by trade, a F-18 pilot from the Marine Corps, and most people know from movies, fighter pilots typically have call signs, a one word, so that you can just holler on the radio someone's name, rather than, hey Randy Bresnik, turn left. It's, hey comrade, break left. And so typically you get it for either doing something stupid or something to do with your name. There's a guy who was on the aircraft carrier, and typically when you get hooked up to the catapult, you release the brakes, and you give him the salute and let him know you're ready to go, and it launches you off. Well, he had his feet on the brakes, so as soon as the catapult goes, both tires blew. You get the call sign, bam bam. So that's a way to get a call sign. Mine, I hadn't done anything stupid, and I got to my first F-18 flight with another Marine instructor, and he said, hey, what's your call sign? And I said, well, I've tried this, this, and this. And he's like, those are no good. I'll think of something by the end of the flight. We came back from my first flight in the F-18, and he sat in the debriefing and goes, Bresnik, that sounds like Brezhnev. We're going to call you Comrade. And then I haven't done anything stupid since.
Nothing you'll admit to anyway.
Or they were able to hand call sign on.
Okay,
Did
thank
you always want to be an astronaut? How did you become one?
For me, I grew up in Santa Monica, California, and I always thought it was fascinating and stuff, but I was just a skinny kid from Southern California, and I never thought it was really possible. But I was fascinated by flying in airplanes. I knew I wanted to be a pilot, and so I was able to apply and get a Marine Corps scholarship to go to school. And so through that process, I was qualified to be able to go to become a pilot, and so that was my dream. And then so here I am, flying F-18s for the Marine Corps, getting the opportunity to go to Top Gun and be a weapons instructor. And then it was like, okay, well, what can I do that's the next level, and the next challenge, and help betterment of, my fellow flyers, and then it was become a test pilot. And then, once I became a test pilot, and then I see, friends of mine get selected to be astronauts. It's like, wow, this maybe could be a possibility. And so it wasn't, it was fortunate that every step of my career brought me closer and closer to it, so that when I applied, fortunately, I was qualified enough to be selected.
So, Randy, can I have you angle just a little bit this way? Just the people around you. And I want to ask you, what makes Yuma just a great area to test these kind of Orion parachutes?
The reason Yuma is so great is because not only the ground facilities and the ranges that we can actually have space to drop the test articles. I mean, look at the fact that we're all able to be here and observe the tests as well. And then the other fact that there's the airspace. I mean, you have to have the ground space and not have the airspace doesn't work for the airdrops. And the fact that the airspace is up high enough that we can do today's drop from 35,000 feet, which is huge. And so, very familiar with these ranges for flying and training as an F-18 pilot, flying out of Miramar and El Toro, where we'd come up here in the aggressor squadron out of Yuma. We'll come out and they help train us on how to do air combat tactics over on the range south of Highway 8. And we'd also do weapons drops and things like that. So, I mean, this is just the ideal, I won't say playground, but training ground for not only tactical aircraft, but also doing these drop tests of tactical vehicles as well as now space vehicles.
And can you explain the details about the future missions where these parachutes will be used?
So the next mission that'll be used after this drop test is the EM-1 mission, where June of 2020 we're going to launch the Orion capsule for the very first time aboard the SLS rocket system, and it's going to be the first time that thing is going to fly as well. And it's going to launch up and go ahead and do a mission that goes around the moon and come back, figure 8 mission around the moon. And it's going to basically do all the testing that allows us to certify the Orion vehicle to be able to put humans on it for the next trip. And so part of that will be coming back at lunar velocities, testing the heat shield, and then deploying these parachutes and making sure that they operate exactly as we expect them to today.
And can you explain the feeling of how it's like being in one of those capsules?
Coming back through the atmosphere, it's a little bumpy as you're actually going through as you're hitting the atmosphere, and the heat shield is taking the brunt of the air particles hitting it, and the heat shield's ablating or breaking off as it burns up, and kind of like an eraser of a pencil. You use it and parts come off, and then the eraser gets smaller. Well, the heat shields do the same thing, but it allows us to decelerate from the speeds that we're going, low Earth orbit, 17,500 miles an hour, or Mach 25, and then we're coming back from lunar orbits, we're talking Mach 32. And so it takes that brunt. And then once you're through that part, and you've gone through seen the plasma at 4,000 degrees outside your windows, and you're now seeing blue again, and you through the heating part, then the parachutes start deploying. The ones that come out and stabilize the spacecraft. For us in the Soyuz, that was a pretty wild ride as the parachutes came out, because the capsule's here, and then they come out, and then there's wild gyrations of the capsule. There's about